Hi, this is Prabha from Database Frameworks team. Today I'm joined by Vladimir from Tenant Scale team. We would like to go through phase 5.2 database sequences epic, which got closed recently, and also would like to give a quick demo in the actual cell towards the end of this recorded session. This epic aims to make sure that all the cells have unique or non-overlapping sequences so that we can move organization between cells without any ID overlapping problem. How we do that is being explained in this design doc. It's sitting inside topology service. So this is the logic which is used for making sure that each cell gets a unique set of ranges for their sequences to pick from. If it's a legacy cell, which is our current GitLab.com database, we are giving 1 trillion IDs, reserving for them. And all the new cells will get 100 billion IDs each. So this validation is set up on the topology services config.toml. So this is our current single source of truth, which holds all the configuration for cells. In this, we have a key called sequence ranges, which is going to hold an array of objects, which includes minval and maxwell. We can see that they are non-overlapping, and also it's not in the so this is for staging, but for production it should be greater than 1 trillion, because the first trillion IDs are reserved for the legacy cell. We can see the workflow of events that makes this work. When we are provisioning a new cell, it calls dbconfigure a rake, which is sitting in our db.rake file, and that calls configure pg databases. Internally, it calls alter cell sequence, which does the which updates the min and max value of each sequences. But before doing that, it also checks the topology services health. While configuring if the topology service is not up and running, we make sure that we raise an error and then exit the configuration part, because we don't want the database to be ready without proper sequence ranges, because that will end up in overlapping sequences. So the topology service health is being checked, and then it goes through the alter cell sequence range method, which does the actual alter sequence command for all the existing sequences with the sequence range, which is coming from the topology service, which is nothing but the min and maxwell of the sequence range array, which is being configured in config.toml. And there is another part to it. So this is for all the existing sequences, but we have to handle new sequences as well. So for that, when we are configuring the database, we do create a event trigger on few commands: create table, create sequence, and alter sequence. What it does is it makes sure that any newly created sequences will get the proper min and maxwell set as well. So that's been done in this particular line. Yeah, that's the internals of it. Now we can see a quick demo of it in an already provisioned cell.
So we are working now on the sales dev cell or sales dev cluster, and this the cell that we have chosen is cell number 4. And as we can see in the configuration, we have a minimum value and maximum value for the sequence ranges configured to be 3 bunch of zeros and 3 bunch of nines. That's how topology service is configured. And if we do have a console, Rails console open on that cell, and we do have a DB console open on that cell. So the first, let's check the cell configuration. So as we can see, we have topology service address configured to be like talking to the topology service on staging. By the way, this is a little bit out of scope of this epic, but topology service, like cell, is talking to topology service using TLS, so the connection is completely secure. And as you see, the TLS is enabled, and we configure TLS key and certificate. Then, in order to get the sequence ranges from the cell, we are executing the cell sequence ranges function. And this function will go and talk to topology service through gRPC protocol and fetch the ranges from the configuration of the cell cell on the topology service. So as we can see here, we received minimum value and maximum value from the topology service, which is completely the same as which is completely the same as here. And then we need to check if the ranges are correct, and we just go and check that in the database. So as we can see, the ranges are correct.
Nice.
That's the end of the demo, and probably you have
Yeah,
something to say about that.
yeah, in addition to this, so this is for existing sequences. Vladimir, maybe we can also create a new sequence in the same PG console, so that we can also like see that the same ranges are applied for newly created sequences as well.
Sure. Primary key.
Right.
Okay.
Yeah.
And
So
it's
we can see
mhm.
that the new sequence also like getting the correct range. Yeah, I think that's the end of it. So all the existing sequence and the new sequence in this particular cell will have the proper range, which is going to be non-overlapping with other cells. Yep.
Yeah.
Awesome.
Yep.
Great.
It
Yeah.
works.
Yeah. Thanks for that, Lorimer. And yeah, I
And
also thought of
sure.
adding a couple of other things. Yeah, maybe I will take the screen now, Lorimer. So once the cell gets its own range and the sequence are consuming IDs from it, we do have a saturation monitoring setup. It's called PGID sequences, which tracks the usage of all the sequences, and it has a hard SLO of 90% and soft SLO of 50%. So we will be paged once it crosses the SLOs. And for example, if we take abuse events underscore ID underscore seek, so which is the primary key of abuse events table, if it's crossing the saturation point, we can increase the sequence range for this particular sequence by calling increase sequence range rake, which is sitting inside db.rake. It gets the new cell sequence ranges. So ideally we will be giving providing another sequence range for this particular cell in the topology service. So if we take cell 4, it had 3 billion to 4 billion initially, and now in order to increase the sequence range for the abuse events ID, we will provide another set of range, which will be, since we have used till 7 billion, it will be 7 billion to 8 billion as the next array in this key. And increase sequence range rake will get that set of sequence ranges from the topology service and then fetch the sequence range which is next immediate to the last used sequence for that particular sequence, and it updates only that sequence range, so that all the existing sequence and the new sequence will continue to use the initial range, which is 3 billion to 4 billion, and any more saturating sequences will again follow the same process of getting called using the rake, and it takes multiple sequence names as well. So that's how we increase the sequence range for now. Uh, for now, it's been done manually, but we also have plans to automate this process. We can have a cron running in the GitLab.com, which will get all the saturating sequence, and it can do it automatically. So there's an issue to track this. And also there is another issue to set the maxwell and minwell for the legacy cell as well. As of now, it's not needed because 1 trillion IDs are more than enough for the legacy cell IDs to grow into, and in order to update the sequence, it also it's dependent on the other concurrent transaction which uses the sequence value. For example, nextval on all the sequences, so we have to do some work and update it. I think it should be okay to update, but we have an issue to track that as well. But these two are not really a blocker, so we moved it out of phase 5.2, and that's the end of it. If you have any questions, feel free to reach out to us. Thanks.